in this episode, how to solve quadratic inequalities. Coming up, back into action. Hey guys, quadratic inequalities and how to solve them. Well, first of all, what is that? It's inequality that containing your term, usually x, raising to the second power. So it's something like x squared. So it's similar to inequality and it has either greater or less or greater than or equal or less than or equal sign in it. So, and basically quadratic inequalities, it's very similar as well to quadratic equations. So, but instead of equality sign, it's either has one of these four. By the way, I have some videos on linear inequalities and you can check it out later, and also on quadratic equations. It's another videos and another approaches. You could also check them out later. Now, get back to that one. First of all, check to see if there is an overall number that you can reduce your inequality, you can divide by. So in this case, just by observation, there is then overall -3 that both sides can be divided. Just one little thing, be careful. If your common term, if your common factor contains x, you cannot divide by x because x is the variable. And if you do, you would lose the solution. So you could do this only with numbers. So in this case, since -3 and -12, they're divisible by -3, so we can reduce other inequality just by dividing this number, -3. So it's fine. So -3 goes away, and on the left side you would get just x squared. And now, because we are dividing by a negative number, the sign of the inequality has to be switched. The sign has to be flipped to the opposite. So this is vitally important. So instead of greater, we would have less. So this is important. Okay, and many people forget to switch, and if you don't do this, so you would go wrong, you would go astray at this point. And since -3 goes into -12, four times, so you would get just 4, +4 there. So we reduces at this point our inequality. Just again, be careful. You cannot do this with variables. You cannot divide by x, for example, or you cannot divide your inequality by another term containing x, like x plus 2, x minus 2. Otherwise you would lose the solution. Now, from that point, the steps are pretty similar what we did for quadratic equations. So you want to bring this 4 to the left side by just subtracting 4 from both sides of your inequality, and that brings us to the next step. So we would have just x squared minus 4 less than 0. So here they cancel. And from that point you want to factor it out. You want to break it down into 2 pairs of parentheses, both starting with x, the variable you are given. And you need to just factor it out. Since 4 is a perfect square number, is 2 squared, This one can be split up easily. It's just 2 and -2. So if you have a quadratic trinomial, a quadratic expression, and I will show you later how. So you need to just split it up using just factoring or factorization. And how to factor quadratic, I have another special video, so you could also check it out. Now, we're looking for two numbers that actually makes your parentheses equal to 0. So in this case, when you plug in -2, your first parenthesis, your entire parenthesis, becomes 0, since -2 plus 2 gives you 0. For the second one, it's 2, since 2 minus 2 is 0. So this axis would make your entire parenthesis equal to 0. The next step, you are going to literally draw a number line that represents all possible real numbers, and you are going to place these two numbers on your number line, so in an ascending order. So -2 comes first and 2 comes second. These two numbers split your number line into 3 intervals. So you have first interval from all numbers all the way to -2, next from 2 and 2, -2 and 2, and 2, and all the way up to infinity. Now, at this point, you need to use the open circle for these two numbers. That means that this value does not include in your solution, because you have just strictly less. If instead you had something like less than or equal to, you would use a shaded circle instead of open. So in this case, so when you have less than 0 or greater than 0, you should use just open circle. That basically means that these two numbers, namely -2 and 2, they are not included in your solution set. But if you have greater than or equal or less than or equal, so instead of this, you would use closed or shaded circle that indicates that these two values, or it could be more, it could be even 1, it could be less or more than 2. So these basically values, that zeros, let's call them, that make your factors equal to 0. That means they are included in the solution set. Now, the next step, you are going to define the sign on each of these 3 intervals by picking a random point belonging to each interval. For example, for this one, you could pick, let's say, -3. This one you are going to pick, let's say, 0, and here 3. Again, you could pick these points randomly, you can select them randomly, but just a pro tip, pick the easiest one, because you are going to substitute, and you don't want to do that much work. So just pick them to make your work easier, so you don't have to do that much work of computing and calculations. So if I pick -3, so you would get, let's say, x your -3, So you're going to plug this negative 3 into your inequality over there. So it becomes negative 3 plus 2, negative 3, negative 2. So it gets negative 1 times negative 5, which is just 5, and that is greater than 0. Basically, to be perfectly frank with you, I'm not interested in value. I don't care what the value I would get. I'm interested in the sign. This is more important for me. And in this case, it's greater than 0. So the sign is positive. So I don't care about the number. So honestly, even you could do these things in your head. You don't have to write it. But I'm just spelling out. So for the second one, you select, let's say 0, and you plug it in over there. So let's just go ahead. When you have 0, you would have just 2 over here, and the second parenthesis would be negative. So a positive number times negative number, again, I don't care what is that. So it gives me a negative. So here is negative. You see? And finally, the last one, you could pick 3. If you go for 3, the first one would be positive, and the second parenthesis would be positive. Even if you pick 4 or 5 or something, they're already greater than 2. So it would be positive. Now, we define the sign on each intervals, and it's kind of alternate. So we have plus, minus, plus. Now, at this point, you look at your inequality sign, and it says we're interested while looking for axes that satisfy your inequality, and they are less than 0. So we are looking at that interval less, so minus. So this interval we're taking into consideration. So we're here, okay? And from that point, actually, you could just write out your answer, because your answer comes from here. So you would just have your all axes that less than 2, and I'm going to use just strictly less, because this I have open circle, and on the other side greater than negative 2. So it's all axes that satisfy this condition, that satisfy this restriction. So it's all axes lying between negative 2 and 2. So this is the interval. So this is the answer using the inequality symbols, inequality signs. If you like, you could come up with the same answer equivalently, but using just interval notation. It's the same thing. If you would write just negative 2, 2, just separate them with the comma, and using the parentheses, brackets, that basically means that your numbers negative 2 and 2, they are excluded, they are not included in your solution set. And we're done with this inequality. Alright, how about this one? So, as I told you before, in this case we have a trinomial, we have a quadratic expression. So it's written in a standard form. It's written in a standard form. So the first thing you start off, you just need to split it out into 2 pairs of parentheses, starting with x. So you need to factor out, in other words. So you have quadratic. And basically, to factor quadratics, as I said, I have another video on factoring, how to solve quadratic equations. So basically, you are looking for two numbers that they multiply to 6 and they add up to -5. And they're gonna be just -2 and -3. Or you could swap the order. So since -2 times -3 gives you 6, and -2 minus -3, so or -2 plus minus -3 gives you this middle coefficient -5. So when we factor it out, you are looking basically for the zeros of your quadratic. So what numbers make your factor equal to 0? So in the first parenthesis it will be x equals 2. So when you plug in x equals 2, your factor becomes 0, and your entire factor becomes 0. For the second one, it's just 3. So basically you're taking the opposite of this number. So it's 2 and 3, so the opposite sign. And basically these two numbers, they are root of this equation, quadratic equation, x squared minus 5x plus 6 equals 0. They are actual roots, or sometimes they are called zeros of that quadratic, zeros. Now, so because they make your quadratic equal to 0, so they're actual roots, the actual solution for your quadratic. If we're talking about the solution of the quadratic equation. Now, the next step, you draw a number line and you are going to place them in a right order. So 2 comes first and 3 comes second. And since you have greater or equal to, you are going to pick the shaded circles that would represent these two numbers. Now you have these 3 intervals, so these two numbers, they split, they break your number line into 3 intervals, and you are going to define the sign on each interval by picking a random point from each interval, plug it into your inequality, and just see what sign your inequality gets. So for this one, you would pick just any negative number, or you could pick even 0. So let's say x equals, let's say -1 for simplicity. So it becomes, just plug it in over here, -1, -2, and -1, -3. So since this is negative number and this is negative number, when you multiply them, the overall would be positive. So again, I don't care what does it equal to, so I only care about the sign. So what I would get, that's more important for me. So I would have overall positive, so all these values would have positive. You could check other intervals, and to be honest with you, the sign is going to be alternate. So here you would have negative and here you would have positive. Well, for this type, to be perfectly honest with you, it's always alternate, but just be careful, because for some of inequalities it's not always like this, so don't get tripped over there. Now look at the sign. So we have greater than or equal to, so basically we are going to interested in these two intervals. So we're here and we're there. So, and you could write your solution set, your answer, as all your x's that less than 2 and your x's greater than, less than or equal. So that's why this shaded circle basically indicates, that shows that your 0 included in your solution, and also x greater than or equal to 3, greater than or equal to 3. So this is your answer, this is your solution set, so it's all your values, so it's infinitely many values. So this is difference between inequality and equation. So it's not 1 or 2 solutions, it's infinitely many solutions. It's a set. If it comes to this, it's a set of all values that satisfy these 2 conditions. If you have to, or if you like, you could write it as using interval notation, and it's the same thing as from negative infinity all the way up to 2, including 2, and typically if a number is included, we use this square bracket that indicates this 2 belongs to your solution set. And all these x's from 3, including 3, all the way up to positive infinity. And for these 3, I'm using as well this bracket square that indicates that your solution also is in there. So this is just 2 alternative ways of writing your answer to this quadratic. So you don't have to write both, you could just pick any of them. I hope it helps you and train your brain, and thank you for watching. I know everyone hates maths, but if you like my video, please click like, share with your friends, leave your comment down below, and be sure to subscribe so you will not miss my new videos.